So in this video, we're going to simplify some rational expressions. So for your first example here, I want you to simplify x squared minus 4x minus 12 all over x squared minus 4. Now, the immediate impulse for a lot of students is to cancel that x squared and x squared. Or even they say, oh, 12 and 4 are nice, that can reduce to 3, right? Well, these are both incorrect. You cannot cancel the x squareds. You cannot cancel the 12 and the 4. To show you what you can cancel, I'm going to do a little side example here. So on the side, let's try to simplify 4x over 2x. So here's one where you can eliminate variables. You can cancel the x's. And the reason why is what I like to call the bubble. In the numerator, you have 4 in a bubble times x in a bubble. In the denominator, you have 2 in a bubble times x in a bubble. Now, what I want you to think about when canceling is, do you have bubbles that match? When you have matching bubbles, that is when you are allowed to cancel. So in this side example, we had matching bubbles of x's, so those could cancel. So only when you have matching bubbles in the numerator and denominator is when you are allowed to cancel. And those bubbles need to match exactly. Then you're allowed to cancel. So if you look back to our original example, x squared minus 4x minus 12 all over x squared minus 4, where is the bubble in the numerator? Well, the bubble is around the entire thing. Same thing with the bubble in the denominator. The bubble is around the entire denominator. These bubbles don't match, so as it's written right now, we can't cancel anything. So we can't cancel anything yet, but maybe we can rewrite the numerator and denominator. Maybe if we factor the numerator into 2 bubbles, we'll have more options to cancel. So let's factor that numerator. Let's do reverse FOIL. This is going to factor to x plus 2 times x minus 6. So now I have 2 different bubbles. Again, just kind of opening the door to more possibilities to cancel. Let's factor the denominator. The denominator factors to x plus 2 times x minus 2. So now I have 2 bubbles that match. X plus 2 and x plus 2 match. So now those are able to cancel. So this leaves me with x minus 6 over x minus 2. Do not get the impulse to cancel those x's. The x's cannot be canceled because what is the bubble? The bubble in the numerator is x minus 6. The bubble in the denominator is x minus 2. Those don't match. They can't cancel. So please don't get the impulse to cancel x's here. Nothing can cancel. So this is our simplified answer. We can't do anything else to simplify, so we can bubble this, we can circle it. That is our final simplified answer. Alright, so I'm just going to do a few examples here to get through this lesson. Here's an example. Multiply and simplify your answer. So just like we were multiplying fractions before, we're going to multiply across. So I'm going to multiply across the numerators. I'm going to multiply across the denominators. And in the meantime, I'm also going to factor it to create some bubbles. So the first numerator, I'm going to factor out 4x. So when 4x leaves the first numerator, what's left over is 1 minus x. And I can check that by distributing the 4x. So if I distribute the 4x, it becomes 4x minus 4x squared. Let's factor the second numerator. That factors to x plus 3 times x minus 2. So I have this string of bubbles that's going to give me a lot of opportunities to cancel. Let's factor the first denominator. That factors to x plus 3 times x minus 1. And the second denominator is just 4x, so we'll just leave that alone by itself. So I have a lot of bubbles to choose from, a lot that can be canceled. 4x and 4x. X plus 3 and x plus 3 is another one that matches. So what are the bubbles that are left over? 1 minus x times x minus 2 all over x minus 1. So you're probably saying to yourself, 1 minus x and x minus 1, those look awfully close to each other. Can't I cancel those? Well, as they're written right now, you can't. And it's for this reason. 3 minus 2 does not equal 2 minus 3. 3 minus 2 does not equal 2 minus 3. So 1 minus x does not equal x minus 1. They're not an exact match right now. But maybe I can factor out a negative 1 and make them match. If I factor out negative 1 from 1 minus x, what are you left with? Negative 1 plus x. I'm going to fill in the rest of the fraction as it is. Because I factored out the minus 1, now I have two bubbles that match. Minus 1 plus x does match with x minus 1. Those are the same. So now I can cancel those. All I'm left with is negative 1 times x minus 2. So that would be my simplified final answer. And we could go a step further. We could multiply in the minus 1. So if I distribute the minus 1 in, I'm left with negative x plus 2. So that's a little bit cleaner looking final answer. So here's another example for you. This one looks familiar. We've done ones like these before using properties of exponents. So if I multiply the numerator across, I get 30 x to the 5th y to the 3rd all over 20 x to the 1st y to the 4th. And again, that was using properties of exponents. Well, we didn't really realize it before, but when we simplified this with properties of exponents, we really were using this bubble idea. When we used properties of exponents, we really were kind of using bubbles to an extent in order to see what cancels. And I'll show you that here in a moment. So let's write the numerator as a series of bubbles. The numerator would be 30 in its own bubble, x to the fifth in its own bubble, and also y to the third. The denominator would be 20 x to the first and y to the fourth. Now, if we're trying to get bubbles to cancel, I'm going to need to separate some of these. So let's write the numerator as 30 x in a bubble and x to the fourth in a bubble. So I separated x to the fifth as x and x to the fourth. In the denominator, I'm going to write 20 x, and I'm going to separate the y's. I'm going to write y to the third in a bubble and y in a bubble. And again, why we're doing that is to get bubbles to cancel. So the matching bubbles can cancel. I'm left with 30 over 2, or 30 over 20, which is 3 over 2, x to the fourth, y. And really, we could have done that easily with properties of exponents. We could have done x to the fifth over x to the 1 is x to the fourth, using 5 minus 1. And we could have done y to the third over y to the fourth. But really, I just wanted to show you the bubbles. Okay, I got one last problem for you. It's a little bit longer. I have multiplication and division. So let's multiply and divide and simplify our answer. So each step of the way, I'm going to try to write bubbles. I'm going to factor if possible to give myself more bubbles to choose from. Remember that when we're dividing fractions, that's like multiplying by the reciprocal. So that's why I flipped that last fraction and I wrote x plus 5 in the numerator. My entire denominator is going to be x plus 5 times 1. And I'm going to factor, or I'm not going to factor yet, I'm going to do it here in a sec, but that 9x squared minus 25 does go to the denominator. When we divide fractions, we must multiply by the reciprocal. So far I see x plus 5 can cancel. That was a matching bubble. And to see if there's any other matching bubbles, I'm going to factor that 9x squared minus 25. So that factors to 3x minus 5 times 3x plus 5. Now I definitely have a bubble that matches, or the bubble that matches and can cancel. 3x minus 5 and 3x minus 5 can cancel. So my final simplified answer, x over 3x plus 5. Nothing can cancel. No more bubbles. So that would be the final simplified answer. So we can box that. No more simplifying after this.